welcome to 5.4. We're going to look at dividing with decimals. It's a lot like dividing with whole numbers, as you can imagine, but there are some extra considerations. We'll look at those. All right, so first let's start off with something pretty straightforward because it's going to divide in nice and evenly. $34.8 or 34 8/10 divided by 4. So what we're going to do is we're going to take the 4, we're going to divide it into 34.8. So of course 4 won't go into 3, but 4 will go into 34. It'll go in 8 times because 8 4s is 32. So we're going to subtract. So there's 2 left over. Now, what we're going to do with decimals is we're just going to keep going, and we're going to bring down the next digit to the right, and we're going to bring this decimal up. So 4 goes into 28 7 times, because 7 4s is 28. So it goes in evenly, because there's no remainder. Nothing left to bring down here. So, and it sort of makes sense that 34 divided by 4 would be around 8. And we can check it by multiplication. So we can set it up as multiplication. That's 28. That's 32, 34, and 1 decimal point in the answer. So we can always check. All right. Let's look at another one. So we're going to set this one up. 35 divided into 1,138 and 9/10. So let's see. 35 won't go into 1, won't go into 11. It will go into 113. 3 30s would be 90, so I'm guessing 3 times. So 3 times 15, or 3 times 5 is 15, excuse me. 3 times 3 is 9, and 1 is 10, so 105. Now I'm going to subtract here. 5 from 3 can't do, so I'm going to borrow. 5 from 13 is 8, so I don't really need that 0 there. Now I bring down the next digit, and I ask, can 35 go into 88? And it can. It can go in twice, because 2 35s is 70. And then I'll subtract. So there's 8 and 1, so 18 remaining. And then I'll bring down the next digit, a 9. 35 goes into 189. How many times? Let's estimate. So 6 times 30 would be 180. So I bet that'll be too big. But 5 30s would be 150. So that sounds about right. So let's see. Oh, what do I do with this decimal here? This comes straight up. And then I think 35 will go in 5 times to 189, because 5 35s. Five times 5 is 25. 5 times 3 is 15, and 2 is 17. So 175. And I'll subtract 14. So I didn't get 0 as a remainder. I have nothing to bring down, so I can add a 0 and bring that down and see how that goes. See if that helps me at all. So 35 goes into 140. It definitely goes into 140. It won't go in 5 times. Maybe it'll go in 4 times. So 4 5s is 20, and 4 3s is 12. Oh, it goes in exactly 140. Okay, so it goes in exactly 4 times, because 4 35s is 140. And then when I subtract, I get 0 as a remainder. And with nothing to bring down, I'm done. So I can add zeros to the end and bring them down, because zeros, trailing zeros to the right of the decimal point, after all my digits, my non-zero digits. They don't change my answer. They don't change the value, so I can add those to see if I can divide evenly at some point. And in this case, I was able to. Okay, so now we're going to divide here, and then we're going to round to the nearest tenth. So 28, obviously it won't go in even a whole time to 2 point anything. So I know it won't go in to 2. And it won't even go into 21, but it will go into 218. How many times? Let's see. So I think 218 is close to 210, and 28 is close to 30, and 30 would go into 210 7 times. So let's try 7 28s. 28 times 7, and let's see how close we get here. $196. I bet I can't get another 28 in to 218. So I'm going to go with 7, because 7 28s is 196. And now I subtract. And that's a 2. That's a 2. And that's a 0. Okay. Now I bring down my next digit. That's a 4. So can another 28 go in here? Let's see. $224. Oh yeah, it goes in perfectly. So that was 7 times, so this would be 8 times. So that'll go in 8 times, because 8 28s is 224. And when you subtract to get 0 as a remainder and nothing to bring down, it means it went in evenly. It just went in evenly a fractional amount. Okay. So now what happens when you want to divide by a decimal? So far we've been dividing into decimals, no problem. But what about dividing by a decimal? So, unfortunately, we can't actually divide by decimals very well because we just don't have a lot of experience dividing and multiplying with decimals in our head. So we don't know the multiplication facts or the division facts very well. So what we're going to do is we're going to turn this into a division with whole numbers problem. So what we're going to do is we're going to say, I'm going to move the decimal over until the divisor here is a whole number. So I'm going to move this over until it's a whole number. The only rule is that whatever I move that decimal by in the divisor, I have to do in the dividend as well. So here would be the decimal in this value, and I would move it over 2 places and then add zeros as I need them. So instead of dividing 17 by 3/100ths, I'm dividing 1700 by 3. And it's a problem that's much easier for me to do because I'm more familiar with whole numbers. Now 3 won't go into 1, but it will go into 17 5 times. And I bring down my 0. 3 will go into 26 times because 6 3s is 18. Bring down a 2. Bring down my 0. 3 will go into 26 times. Because 3 6s is 18. And I have 2 left over. So if I were to add a decimal point and add a 0 and bring it down, 3 goes into 26 times because 6 times 3 is 18. So I can see that this pattern is repeating here. So no matter how many zeros I add, this is always going to go in 6, and I'm always going to be left with a 2 as a remainder. So I can write it like this. I can write it like 566.6 repeating, or in the case that I'm asked to round to the nearest tenth, then what I should do is I should actually go to the hundredth, look at that neighbor number, see that it's a big one, see that it's going to push that 6 up to a 7. So this is really going to be 566.7 when rounded. All right, so let's review a little bit about dividing with decimals. So the answer to the division problem in example 1, and we didn't actually do example 1, but we will still be able to look at this in decimal notation. So this is 298 and 7/10. So that's 298 and 7/10, decimal notation. All right, in example 4, we place a 0 at the end of a number without changing the value of the number. Why is the placement of the 0 helpful? Because if you have a number, you may need to add a 0 after the rightmost decimal value in order to line them up. Or if you're doing division, so that you can continue doing division into the same number but into an increasing place value of that number. C, the expression, this expression here, is equivalent to the expression because each number was multiplied by what? So if I want to turn my divisor into a whole number, in this case, if it's in the hundredths place, what do I have to multiply by to make it a whole? Well, hundredths, I have to multiply by 100 to make it a whole. So if I have 0.25 and I multiply by 100, I'll get 25. And I have to multiply my other number by 100 as well, moving the decimal point 2 to the right effectively, to keep my expression equivalent. So it was multiplied by 100 in this case. All right, D. Briefly explain how to divide with decimals. Well, it's not that brief, but in short, I suppose, it's like dividing with whole numbers. You bring your decimal point up when it's in your dividend, and if you have a decimal point in your divisor, you need to multiply your divisor and your dividend by whatever power of 10, hundredths, thousandths, in order to make your divisor a whole number, and you multiply your dividend by that same value, of course, to keep it equivalent. And then bring your decimal point up if you still have one in your dividend, and divide as usual. So hopefully that helps you answer D in your own words. And if you have questions, be in touch. And I'll see you in the next section.